and welcome to our Calculus Smarty Party. Today, first we're going to be learning the product rule. The product rule, the formal definition, because it's also known as Leibniz rule, it's to find the derivative of two things multiplied by each other. You multiply the first function by the derivative of the second, and add that to the second function multiplied by the derivative of the first. With the product rule, the order of these two operations doesn't matter, but it does matter with other rules though, so it helps to use the same order each time just to be sure. Okay, so there are two basic formulas. They mean the same thing, it just matters which one you like better. And you're going to assume that you have two functions, u and v, and you're going to have the function u multiplied by the derivative of v plus the function v times the derivative of u. And that's the formula. The first problem is f of x equals x plus 1 times x minus 1. So you're going to have x plus 1 times the derivative of x minus 1 plus x minus 1 times the derivative of x plus 1. So it's going to be x plus 1 times 1 plus x minus 1 times 1, which is going to eventually equal x plus 1 plus x minus 1, which will give you 2x. For our second example for product rule, we have x squared minus 4x plus 3 times x plus 1. And then you're going to have the derivative of x squared minus 4x plus 3 times x plus 1 plus x plus 1 derivative times x squared minus 4x plus 3. So it's going to equal 2x minus 4 times x plus 1 times x squared minus 4x plus 3, which is going to equal, if you expand the 2x minus 4 times x plus 1, that will equal 2x squared plus 2x minus 4x minus 4 plus x squared minus 4x plus 3. Then you're going to add up all your like terms, and then you should get 3x squared minus 6x minus 1. For our third example of product rule, we use trig with this one. And so it's going to be x times sine of x. So you're going to have x times the derivative of sine of x plus sine of x times the derivative of x. So it's going to be x cosine x plus sine x times 1, which will give you x cosine x plus sine x.
Okay, so next we're going to learn about quotient rule. And the formal definition of quotient rule says that the quotient of f of g, which you can see down here, of two differentiable functions f and g is itself differentiable at all values of x for which g of x does not equal 0, because you can't have a 0 in your denominator or else it will be undefined. Moreover, the derivative of f over g is given by the denominator, g of x, times the derivative of the numerator, the derivative of f of x, minus the numerator, f of x, times the derivative of the denominator, the derivative of g of x, all over your denominator squared. And as you can see, g of x still can't equal 0, because you can't have a 0 in your denominator. So that's the definition written out in words, and this is how you would see it written out mathematically. And it's kind of a long formula to remember. It's longer than product rule. So a lot of people in our class say low d high minus high d low all over low low to help them remember this long formula. Okay, so along with quotient rule, there's constant multiple rule, which basically just says that some quotients can be considered the product of a constant times a function of x. So you can use simple algebra to factor out something and get a coefficient. So like x squared plus 3x over 6 becomes 1/6 times x squared plus 3x. And you don't have to use quotient rule. And then in this example, you have negative 3 times 3x minus 2x squared over 7x. And then you factor out an x in your numerator, and you get negative 3x times 3 minus 2x over 7x. And then your x's cancel out, so you have negative 3/7 times 3 minus 2x. So practice problem for quotient rule. Differentiate f of x equals x over x squared plus 1. So to find the derivative of f of x, you take your denominator, x squared plus 1, times the derivative of your numerator, which is 1, minus your numerator, x, times the derivative of your denominator, 2x, all over your denominator, x squared plus 1, quantities squared. And then once you distribute all that, you get x squared plus 1 minus 2x squared over x squared plus 1 squared. And then you combine your like terms, and your final derivative is 1 minus x squared all over x squared plus 1 squared. Okay, so for the second practice quotient rule problem, it says differentiate h of x equals the cube root of x all over x cubed plus 1. So to differentiate, you have your denominator, x cubed plus 1, times the derivative of your numerator, which you apply power rule, and you get 1/3 x to the negative 2/3, and then minus your numerator, x to the 1/3, times the derivative of your denominator, which is 3x squared, all over your denominator squared. And so then you kind of have a problem here because you have a complex fraction and you also have a negative exponent, which you never want. So you're going to multiply by 3x to the 2/3, and you get over 3x to the 2/3, because it's like multiplying by 1. And you get x cubed plus 1 minus x to the 1/3 times 3x to the 2/3 times 3x squared, all over 3x to the 2/3 times x cubed plus 1 squared. And then you multiply all this out, and you'll get x cubed plus 1 minus 9x cubed, because when you multiply x to the 1/3 times 3x to the 2/3, you get 3x, and then times 3x squared, you get 9x cubed. And then all of that is going to be over 3x to the 2/3 times x cubed plus 1 squared, and then you combine like terms in your numerator, and you get 1 minus 8x cubed all over 3x to the 2/3 times x cubed plus 1 squared. And the last practice quotient rule problem says differentiate h of x equals t squared plus 2 over 2t minus 7. So you have your denominator, 2t minus 7, times the derivative of your numerator, which is 2t, minus your numerator, t squared plus 2, times the derivative of your denominator, which is 2, all over your denominator squared. And then you multiply everything out, and you get 4t squared minus 14t minus 2 squared minus 4, all over t squared minus 7 squared, and then you combine like terms, and you get 2t squared minus 14t minus 4, all over t squared minus 7 squared, and then you have to factor out a 2 in your numerator, and you get 2 times quantity t squared minus 7t minus 2, all over t squared minus 7 squared. And that is quotient rule. Okay, so next we're going to talk about higher order derivatives. And basically, after you take the first derivative of a function, you can take the derivative of the resulting derivative function, and that would be called a second derivative. And then if you take the derivative of your second derivative, it's a third derivative, and so on and so forth. And the real-life application of higher order derivatives would come if you have a position function, and then if you take the derivative of your position function, you get a velocity function. And then if you take the second derivative of that same position function, you get an acceleration function. So this is how you would see higher order derivatives written. So of course you have your first derivatives that you're pretty familiar with by now, and then second, third, fourth, and then nth, which is just substitute in a number for n. And that's how you denote higher order derivatives. And then practice problem, find the second derivative of f of x equals x plus 32x to the negative 2. So your first derivative, you have to find your first derivative first, and it's 1 because that's the derivative of x, minus 64x to the negative 3 because you applied power rule, which simplifies to 1 minus 64 over x cubed. So that's your first derivative. And then your second derivative is you just take the derivative of this function. So you get 192x to the negative 4 because the derivative of 1 is 0 because 1 is a constant, and the negatives cancel out. So you should write it as 192 over x to the 4th. And then find the given higher order derivative. So you're given that the fourth derivative of f of x equals 2x plus 1, and you're asked to find the sixth derivative of f of x. So you have to find your fifth derivative first, which is 2, and then your sixth derivative would be 0 because 2 is a constant. Okay, so now comes the acceleration, like real-life application of this. So it says an automobile An automobile's velocity starting from rest is v of t equals 100t over 2t plus 15, where v is measured in feet per second. Find the acceleration at 5 seconds. So you're given a velocity function, so that's already the first derivative of a position function, so you're looking for the second derivative of your position function, which is the derivative of this function. So you have to use quotient rule, and you have your denominator 2t plus 15 times the derivative of your numerator, which is 100, minus your numerator 100t times the derivative of your denominator, which is 2, all over your denominator squared, which is 2t plus 15 squared. And once you multiply all that and combine like terms in your numerator, you get 1500 over 2t plus 15 squared. And then all you have to do is substitute in your time, and you'll get 1500 over 2 times 5 plus 15 squared equals 1500 over 10 plus 15 squared equals 1500 over 25 squared equals 1500 over 625, and then you have to simplify that down to 12 over 5. And that is how you use higher order derivatives.
Alright, so you also need to know the derivative trig functions. These personally are my favorite because they're all just memorizing, and you just need to know them. They're fantastic. And so if you're finding the derivative sine of x, it's going to equal cosine of x, and if you're finding the derivative cosine of x, it's going to equal negative sine of x. And if you find the derivative tangent x, is going to equal secant squared x. And if you find the derivative cotangent x, is going to equal negative cosecant squared x. And if you're going to find the derivative of secant x, is going to equal secant x tangent x. And the derivative of cosecant x equals negative cosecant x cotangent x. Another way to help you memorize all these things is if the derivative of it originally starts with c, like cosecant or cotangent or cosine, it's going to end in a negative derivative.
Okay, so that was our video on product rule and quotient rule and higher order derivatives and derivatives of trig functions. So I hope it was helpful to you, and good luck!